Hello, so we are looking at the flaming Bunsens experiment. Ben and Liz are arguing about Bunsen burners. Ben says two Bunsens heating up some water will heat it up twice as fast as one burner. Liz disagrees. She says two Bunsens won't be twice as fast. It'll be faster, but not twice as fast, because a lot of heat gets wasted to the surroundings. What is your prediction? So hopefully by now you've made your prediction. The equipment that we are going to use is in front of us here. We've got a Bunsen burner. There's just a Bunsen burner just outside shot. I'll bring that back in a second. We've got a tripod and we've got our beaker. We're going to add 100 millilitres of water to that beaker using our measuring cylinder, and I'll do that now in actual fact. Notice I'm wearing goggles. Safety, safety, safety. And there we go. So the 100 ml of water goes into the beaker, and then we take the temperature as a starting temperature. We turn on the Bunsen. As soon as you turn on the Bunsen, you turn on the stopwatch as well, and you now take the temperature. When the temperature of the water reaches 85 degrees centigrade, you stop the stopwatch. So let's say, for example, we just hit 85 degrees centigrade, stop the stopwatch, and we get a time. That's the first part of the experiment. The second part of the experiment would be to completely start from scratch again with water at room temperature, still 100 ml of water, and we're still using just water. It's not oil, it's not Coca-Cola, it's just water. And now what we do is we placed not one, but two Bunsens underneath. Turn them on, start the stopwatch, record the temperature using your thermometer, and when it reaches 85 degrees centigrade, you once again stop the stopwatch. So if we just go through some of the variables, what are we changing here? Well, what we're changing, the independent variable, would be the number of Bunsens. The dependent variable, what changes as a result, would be the time it takes for the temperature of the water to reach 85 degrees C. So that's a time value. Control variables here, what do we keep the same, I wonder? Well, we're going to keep the type of liquid that we're using the same. We're going to keep the volume of the liquid the same. We're also finally going to keep the starting temperature of the water the same. Make sure that you fill in your results table and conclusion, and you write in the method, and have a go at questions 1 to 6 as well. I wonder if your prediction was correct. Anyway, see you soon. Bye.